Welcome back to my recorded classes. This recorded session we are discussing a topic from module 4 counting, that is 4.2, the pigeonhole principle. So before starting the session, all of you please subscribe my channel for getting more recorded classes. So let's start the topic. 4.2, the pigeonhole principle, correct? So let's start with one example for understanding pigeonhole principle very easily. Pigeonhole principle. So let be a sub case, okay? That a pigeonhole principle we can say with by using one example like this. Let me explain that one. Let there are 10 pigeons and 9 pigeonholes are there, okay? There are 10 pigeons. You can see this figure. We have 10 pigeons are there and 9 pigeon holes are there. See, this is one pigeon and one pigeon hole, another pigeon and in the pigeon hole. This is the third one, correct? This is fourth one, fifth, sixth and 7, 8, 9 and 10, correct? Two pigeons are there and we have 9 pigeon holes. 10 pigeons and 9 pigeon holes. That means pigeon number is more, pigeon hole is less, correct? Then what the pigeonhole principle is telling, at least one of the pigeonhole, we have 9 pigeonholes are there here, at least one of the pigeonhole should accommodate 2 or more pigeons, 2 pigeons or more pigeons, correct? See, you can see all the holes one pigeon only except this hole, correct? The last hole we have 2 pigeons are there in the last hole, correct? Here. So what the pigeonhole telling, if pigeon number is more, pigeonhole less means at least one of the pigeonhole should accommodate 2 pigeons or more pigeons. See, this is the simple idea, live example. You can see that pigeonhole you can understood very easily by using this figure, correct? That means pigeon number more, pigeonholes less means at least one of the, at least, okay, minimum. At least one of the pigeonhole should accommodate 2 pigeons or more pigeons. So this is the idea of the pigeonhole principle. So you can see, let me explain that rule, that pigeonhole principle generally like this, okay? Let k be a positive integer and k plus 1 or more object we have k plus 1 or more object. Object means it is like pigeons, okay? Object means here it is meaning like a pigeon. So we have k plus 1 or more pigeon. For example, last example we are taken 10 pigeons, correct? 10 pigeons, like k plus 1 means 10 there, and are placed in a k boxes. This is placed in a k boxes. Boxes means nothing but it is pigeon holes, correct? It is the pigeon holes. Then what the rule is telling, then there is at least one box. At least one box means at least one pigeon hole, correct? At least one pigeon hole containing 2 or more of the object. Object means pigeons, okay? So the previous example you can read like generally like this. If k plus 1 pigeons, that means 10 pigeons are placed in k boxes, that means 9 boxes. Last example it is 9 pigeon holes, okay? Then there is at least one box containing 2 or more the object, correct? So whenever pigeon is more, one of the pigeon holes should have 2 or more object will be there, or pigeons will be there. Now let me see another example here. Example 1 here. In a group of 367 pupils, okay? How many pupils are there? 367 people. 367 people means 367 pigeons are there, correct? 367 pigeons, like people or object, like that things we are taking here like pigeons. Then what telling, at least 2 people must have same birthday, okay? At least 2 pupils must have the same birthday. Because what is the reason? Because we have 366 birthday in 1 year, inclusive of 29 February during the leap year, correct? Leap year we have 29 February will be there, so totally 366 days will be there in leap year, okay? In leap year, how many days will be there? 366. Normally 1 year means 365 days. But in leap year, February 1 day extra, 29 days will be there. So 366 days will be there, leap year, correct? But how many pupils are here? Number of pupils means, correct? number of people, okay, in this question, it is 367. So what is the meaning here in this question? We can compare with the pigeons. Number of peoples means it is like pigeons, correct? It is like pigeons. And leap year, correct? Leap year 366 days. Days means it is like pigeonholes, correct? It is like pigeonholes, days, okay? So 367 and 366, okay? Peoples are more, but the days are less, 366. Pigeonholes will be less. Pigeons are more, pigeonholes will be less. So what we can say, at least, okay, at least two people have same birthday, at least two people, same like the pigeonhole principle, okay? So that is the idea behind here in this question. Now before coming to the next example, you can see some of the cases we need to know. How many days in a week? There are 7 days. What are the days? We have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, correct? We have 7 days, because some of the examples when we are discussing, it is helpful to you. Already you know that one, but I am just telling that one. 7 days are there. Now in an year, correct? In an year, normally how many days will be there? 365 days, correct? 365 days normally, correct? Normal years 365 days. But if you are in leap year, how many days will be there? 366 days, correct? 366 days in leap year. Now leap year means, you know what is the meaning leap year? What is the meaning leap year? Actually that month, that year, February should be 29. Normal year means February should be 28. That is why 1 day extra is coming. 366 days in a leap year, correct? You know that idea. Now you know how many months are there in an year? That is 12 months, correct? 12 months, of course you know all of these things, 12 months will be there. And you know gender means what are the possibilities? Generally male or female. How many possibilities are there? 2 possibilities, correct? So number of possibility means 2 possibility. That means male option or female option, okay? So before starting the questions, okay, you can just see these things. Now let me go to the extended pigeonhole principle. Extended pigeonhole principle. Now pigeonhole principle, how we are writing in general way, okay? We discussed with example already. We have 10 pigeon and 9 pigeonhole means at least one of the pigeonhole should have 2 or more pigeons, correct? Now this rule, how we can write it generally? If we have n pigeons, if we have n number of pigeon, 10 pigeon, like that, you can assume like if we have n pigeon, for example that example we have 10 pigeons, like assigned to m pigeonholes, okay? M number of pigeonholes. In the previous example it was 9 pigeonholes was there. Which is the greater number? N is bigger number and m is small number. What is the meaning? N means number of pigeon. Number of pigeon is always more and number of pigeonhole is always less, correct? M number is less. Then one of the pigeonhole must contain at least, okay, all of you remember this function, seal function, we are studied in 3.2 section. At least one of the pigeonhole must contain at least the seal function n by m pigeon. One of the pigeonhole must contain at least seal function n by m pigeons, okay? Now what is the meaning the sealing function? Sealing function n by m means the sealing function, the smallest integer greater than or equal to that number, x, greater than or equal to x, smallest integer greater than or equal to x. X means this n divided by m, okay? X means n divided by m, we can check by calculator. The smallest integer greater than or equal to that number we are calling the sealing function, okay? So before coming to that extended pigeon rule, you can see some examples of the sealing function, Okay, ceiling function of 25 divided by 7. Actually, 25 divided by 7 means 3.571. So, ceiling function 25 by 71 means take the next integer number. Okay, after 3.571, which is the next integer number, you can take that one because the smallest integer greater than or equal to that number. Correct. So, what is the next number? Actually, it is 4. So, what is the answer we are getting? Ceiling function 25 by 7 means it is equal to 4. Correct. Now, ceiling function 25 by 8, 3.125. What is the next integer number? It is equal to 4. Ceiling function 50 divided by 9. Ceiling function 5.555. 50 divided by 9 means 5.555 equal to next integer number is 6 number. Okay. So, smallest integer greater than or equal to that number. Greater than or equal to that number. When we are taking equal, actually, for example, if you want ceiling function 7, ceiling function 7 is already integer. So, take ceiling function 7 means same as 7. Okay, I hope you understood. So, if it is not an integer, take the next number. Okay, if it is already an integer means the same number. Okay, ceiling function 7 equal to 7 or ceiling function 6 equal to same number, that is 6. So, what is the extended pigeonhole principle is telling? If we have n pigeons assigned to m pigeonholes, always pigeon number is less and pigeonhole is less, means one of the pigeonhole must contain at least n by m ceiling function pigeons. Okay, so this is the idea here we are doing. Okay, now let me go to some example. Assume that there are 30 students. Okay, there are 30 students. How many number of students? There are 30 students. Student means always take it as pigeons. Okay, whenever we are doing questions, you can assume what are the pigeons and what are the pigeonholes. How many pigeons and how many pigeonholes? Correct. So, students means it is like a pigeon. How many pigeons are there? 30 pigeons are there. Pigeons we are representing by n letter, n equal to 30. In math for computing class, okay, assume that there are 30 students in math for computing class. Show that at least 2 students. Show that. Okay, show that means just to verify. Okay, show that means just to verify at least 2 students. This is the answer actually. Answer already given. Just to verify this answer. Okay, show that at least 2 students have their names begins with the same letter. Okay, have their names begin with the same letter. Okay, that letter is important. Same English letter. Okay, so number of English alphabet, because it is related with the English alphabet letter. How many English alphabet are there? M equal to 26. So, English alphabet means we can call it as pigeonholes. Okay, pigeonholes. So, how many pigeonholes will be there? 26, correct? Pigeons means number of students, it is 30. Now, what we need to do? Show that at least 2 students, their name begin with the same letter, correct? That means one of the letter, 2 or more students name starting. That is what we need to do here. So, what we do? According to the pigeonhole principle, extended pigeonhole principle, what we can what is the rule for that one? Ceiling function n divided by m equal to, correct, and now at least one of the pigeonhole, how many pigeon will be there? Ceiling function n by m. So, ceiling function n by m equals the ceiling function, what is the n number? 30 divided by m number 26. So, when you are calculating 30 divided by 26 means 1.1538. So, we can take the next number, that is equal to 2, correct. So, what we can say? At least 2 students have their names begin with the same letter. That means one of the letter is the pigeonhole here, correct. So, one of the pigeonhole, that means one of the letter must have 2 students starting, correct. 2 students, their name starting with the same letter. That is the meaning in this question. So, I hope you understood that one, equal to 2 here. So, answer is given in the question. Show that at least 2 students. 2 is the answer. So, we need to just verify. Show that means just to verify that answer is correct or not by using pigeonhole principle. Okay, now let me go to another example. You can see the example. Assume that 90 students. How many students? 90 students have registered in Math for Computing course. Okay. Show that among them at least 8 students were born in the same month. Okay. So here month is the pigeonhole. Keep in your mind, month means it is the pigeonhole. Correct. Students means it is pigeons. All the question assume like pigeon, what is pigeon and what is pigeonhole. Okay, so we have 90 pigeons. So since there are 90 students, n equal to 90. N equal to 90 means we have how many pigeons are there? We have 90 pigeons are there. Correct. Now related to the month, our question. So number of month in an year means how many month will be there? 12 month. So this is what we are calling pigeonholes. Correct. So how many pigeonholes? 12 pigeonholes. Now what is our question actually? Show that we need to verify. Correct. We need to verify among them at least 8 students were born in the same month. That means one of the month 8 students birthday is there, born month will be there. Okay, one of the month. Okay, 8 students born month, one of the month. That what we need to verify here. So we can do this question. So according to the extended pigeonhole principle, okay, we can check by the ceiling function n divided by m. That means the ceiling function 90 divided by 12. 90 is the pigeons and 12 is the pigeonhole. So ceiling function 7.5. Ceiling function 7.5. Correct. 7.5 means what is the ceiling function? Next number. 7.5 means 8 number. So how many students in the same month? One of the month. Correct. One of the month. Out of this 12 month, one of the month at least 8 students were born. Correct. So that is what our question. 8 students were born in the same month. So that is the idea of the question of the pigeonhole principle. Correct. Now next we are going to the exercise. Okay, so I hope you understood the pigeonhole principle. Now we are doing the questions one by one. First question: there are 27 students in a class. Okay, and there are 12 possible grades. Okay, there are 27 students and there are 12 possible grades. What are the 12 possible grades actually? F grade is there. In an examination, when you are doing grading system, what are the 12 grades? You can hear F grade, failed, D, D plus, C minus, C plus, B minus, B plus, A minus, A and A plus grade. 12 grades are there. Correct. Now what is our question in a course assessment? Show that. Show that means verify. Correct. Verify at least 3 students. This is the answer. Okay, answer already given. At least 3 students will receive the same grade. Okay, so in this question just assume, okay, what is pigeon, what is pigeonhole? 27 student. Okay, students means it is pigeon. So I am writing number of students n equal to 27. This is like pigeons. Correct. Now pigeonhole is what here? Grade, because assigning grade. The students we are assigning grade. Correct. Pigeons are going to the pigeonhole, like that. Students, okay, we are giving grades assigning. Okay, so number of grades we can write. Number of grades here, how many grades will be there? Equal to 12 possible grades. Okay, so this is what we are calling pigeonholes. So keep in our mind these two ideas: students like pigeons, grades like pigeonholes. Now we need to verify at least 3 students will receive same grade. Okay, so one of the grade out of F, D, D plus, one of the pigeonhole, one of the grade. Okay, at least minimum 3 or more students will have. Correct. That is what our question. So according to the extended pigeonhole principle, ceiling function n by m equal to ceiling function, what is n here? 27 divided by what is m? That is 12. Correct. So ceiling function 27 divided by 12. So what is that number? You can check by calculator. Ceiling function 2.25. That means equal to next number 2.325 means the number 3, correct, next integer number. So we got the answer. What is the answer we got? At least 3 students will receive the same grade, correct. That means one of the grade 3 students will get it minimum, correct. So that is the idea here in this question. I hope you understood. Okay, let me go to the second question now. Okay, there are 28 different time period. Okay, keep in your mind, there are 28 different time period during which classes at a university can be scheduled. Okay, you know, time period means sometime classes 8 to 9, one time period, correct. One class teaching will be there. 9 to 10 another time period, 10 to 12 another time period, 12 to 2 another time period, like that 28 different time periods during which classes at a university can be scheduled. If there are 567 different classes, okay, we need to schedule how many classes? 567 different classes we need to schedule. How many different rooms will be needed? This is the question here. Now what are the idea here? It is, you can see, we have time period, correct, and we have different classes 567 different classes. So what is the idea here? What is the pigeon and what is the pigeonhole? You can see always pigeon number will be bigger number. That is one of the idea. But think logically, how we are doing? Classes we are scheduling in the time period, correct. One class, for example, math class, we are scheduling 10 to 12, like that, correct. So classes, each course, okay, we are scheduling into the time period, correct. The time period, for example, as I told you, math class scheduling, for example, 10 to 12, like that time period. So what is the pigeon and what is the pigeonhole? I hope you understood. What is the pigeon actually? Number of different classes. How many classes we have, correct? How many classes we have here? 567 classes are there. 567, correct. Now these classes we need to arrange in a time period, correct. So we can say the number of time periods, okay, m equal to 28 are there. 28, correct. I hope you understood. Equal to 28. So here, as I told you, this one is the pigeon and this one is the pigeonholes. Now what we need to do? How many different rooms will be needed? So what we do actually in the pigeonhole, so we can check that one in the different time period. One of the time period, correct, one of the time period, how many different classes we need to schedule? That is what we need to think in our mind. Okay, so what we do? We are just using the extended pigeonhole principle. Ceiling function n by m equal to ceiling function, what is n? 567 divided by 28, correct. So you will get the ceiling function when you are entering your calculator, 20.25. Ceiling function 20.25 means next number, that means 21, integer number 21. So what is the meaning of this 21 actually? One of the pigeonhole, okay, must have at least 2 or more, like we are telling the pigeonhole principle. So like that, at least one of the pigeonhole, that means at least one of the time period, because here the pigeonhole is time period. At least one of the time period, what we can say, at least one of the time period in which at least 18, sorry, not 18 here, it is 21 here, not 18, it is mistake. 21 classes, class meeting are scheduling, since each class meet different rooms, correct. So how many rooms are needed? 21 classrooms needed here. Okay, I hope you understood. Okay, as per the generalized pigeonhole principle or extended pigeonhole principle, at least one of the time period, okay, at least 21 classes meeting we need to schedule. Since class must be different rooms, we need how many rooms? 21 classrooms we are needed, correct. So that is the idea of this question. Okay, now let me go to the number 3, question number 3 here. You can see the question. In a group of 29 people, in a group of 29 peoples, okay, how many would have been born on the same day? Okay, how many of born in the same day? That is the question. So what is the pigeon and what are the pigeonholes? You can see people are the pigeon, correct? So group of 29 people, number of peoples we can write 29. This is what we are calling pigeons. Okay, now born on the same day, day is the pigeonhole. Okay, so number of days means, okay, number of days means how many days are there in a week? 7 days, correct? So this is what our pigeon holes, correct? Number of days means week, in a week how many days, like Sunday, Monday, correct, Tuesday, okay, as I told you, Wednesday, Thursday, Friday and Saturday, correct? So 7 days, that is what number of days. So number of pigeons means 29 peoples. How many pigeonholes? 7 pigeonholes. Okay, born on the same day means born day, correct? Birthday, that day when we are taking day, what are the day possible? Sunday, Monday, Tuesday. They are born either Sunday, Monday or Tuesday or Wednesday or Thursday or Friday or Saturday, correct? These are the option. Out of the 7 day, one of the day. So what is the pigeonhole? Pigeonholes means this day. So one of the pigeonhole, correct? How many would have been born the same day, correct? So that is what our question. So we use the extended pigeonhole principle. N by M ceiling function equal to ceiling function 29 divided by 7. What is the what is the ceiling function 29 divided by 7? We can check. Ceiling function 4.14, correct? That means ceiling function 4.14 means next number, that means 5. So what we can conclude that one? How many would have been born on the same day? 5 peoples, correct? One of the day, for example Sunday, one of the day we can take 5 peoples. Okay, 5. How many would have been born? 5 would have been born that same day. Okay, so that is the idea of the question. Now same question, number of peoples is 29. On the, how many would have been on the same month, born on the same month? That is the question. Okay, so first one, pigeons are same, n equal to 29. Number of peoples are 29, are same as the A part. So number of pigeons are 29. Now how many would have been on the same month? That is the question. Month is the pigeonhole here, correct? So how many months are there in an year? M equal to 12 months are there, correct? M equal to 12. So this is the pigeonhole. Pigeonholes, correct? Now we need to check the extended pigeonhole principle. Ceiling function n by m equal to the ceiling function 29 divided by 12. You can check that one. The ceiling function 2.41 will get it. What is ceiling function 2.41? 3. So how many would have been on the same month born? 3 peoples. Okay, 3 peoples would have been born on the same month. That is the idea here. Hope you understood that one. Okay, now questions are all same idea only, easy questions. At a university, okay, next question. At a university there are 365 teaching staff. There are 367 teaching staff employed from 8 different countries. Okay, how many countries? 8 countries. 8 different countries. Show that means we need to verify. We need to verify at least 80 of them. Answer is given already. Answer just we need to verify. Okay, show that 80 of them have the same nationality. That is the question. Okay, so what is the pigeon here? Pigeon means number of teaching staff, correct? Number of teaching staff. So n equal to 637. This is the pigeon, number of pigeons. Number of pigeons equal to 637. Now what is pigeonhole here? Country, correct? Nationality, which national, which country, that one, correct? So How many countries are there? Number of countries, correct? M equal to 8 countries are there. So this is the pigeonholes, correct? Pigeonholes. So country, name of the country is the pigeonhole. Nationality, that is the pigeonhole. Now what is the question? Show that at least 80 of them, 80 teachers, okay, have same nationality. So one of the country, 8 pupils minimum, okay, minimum 8 pupils from one of the country. That is the idea here, minimum 80 pupils. So we are using the extended pigeonhole principle. Ceiling function n by m equal to ceiling function 637 divided by 8 we are getting. So when we are calculating ceiling function 79.625 we will get it. What is the ceiling function? 79.625 means next number, that is 80, correct? So what we can conclude? At least 80 of them have same nationality. One of the country, 80 pupils, 80 teaching staff, okay, minimum. So that is the idea of the pigeonhole principle here. So here answer is given, that is the another thing, verify or show that 80 of them have same nationality. Hope you understood that one. One more question we can do, question number 5 here. Suppose that there are 27 students. How many students? 27, okay. Suppose there are 27 students in a calculus class. Show that the class must have 14 male students and or at least 14 female students. Show that the class must have at least 14 male students or at least 14 female students, correct? So what is the pigeon here? Number of students. Number of students. How many students? N equal to 27. Now what is the pigeonhole here? 14 male and female. Male and female. Gender, correct? Gender is the pigeonhole. So M equal to 2 here. Gender means either female or male, correct? So this is the pigeons number, and this is the pigeonholes. How many pigeonholes? 2 pigeonholes. So 27 students, 2 pigeonholes, male or female, correct? Now we are checking that one of this option, or male option or female option. At least how many students will come in male option or female option. That is the idea here, okay? So as per the extended pigeonhole principle, the ceiling function n by m equal to the ceiling function 27 divided by the number of pigeonholes. What is 27 divided by 2? The ceiling function 13.5. That means 13.5 means the next number 14, correct? So what we can conclude? The class must have at least 14 male student or at least female student. One of the whole, correct? One of the pigeonhole. One of the pigeonhole means what is the meaning? Either male or female, correct? So one of the pigeonhole, that means at least 14 male students or at least 14 female students will be here, okay? So this is the idea of the pigeonhole principle. So I hope you understood the idea here. Almost questions idea same. We did some questions here. I hope you understood the idea, pigeonhole principle. So thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.